I would like to.
All this year.
Yeah. Yeah, we need to figure that out. May have to do it during a review day. Oh, I got the wrong book open.
It's such a pretty day outside.
Luke, you better wear jeans on kickball day? Or we don't. The jeans come out. Can we pick teams? We have a jean team for everyone else. So we don't have.
Wear jeans on Monday.
Yelling at Mr. Murray.
You don't even notice.
Jeans or khakis. Jeans and khakis.
I had my pranas on. Oh, stop.
Jeans
it.
plus ginger. Jeans and ginger.
What if we just?
Oh, wait, did I pay for this?
All right, guys, here's where we are. Today is kind of a practice day. But I want you to look up here. We're on more trig derivatives in AD 101. And I want you to just kind of look through here. And I'm going to just find a couple of random ones and see if you see what I see. So I am looking at number 2. To take a derivative of number 2, y'all with me? Everybody okay?
Yep.
All right.
Yeah.
Watch some drama hit.
We just found the natural
We're gonna make it.
and realized it was due April 8th. But it not happen. It's a little bit past April 8th.
You can
They just handed that out?
No, they handed this out a while.
You just found it.
I just found it.
Yeah, it's unfortunate.
Well, I have no idea. Back to this.
All right, focus. What do you see when you see number 2 and somebody asks you to take? So you see a product rule, great. What do you see on number 3? That's it? And a product when you get to the D low, right?
Yeah.
All right, what do you see on problem number 6?
First, second, first.
So you see a product rule? And when you get to the D second, what do you see? A big chain rule, right? Starting with the power, then with the trig function, then with the 5x. If I'm bothering you, or if I'm do what? 99? Okay, 99. All right, tell me what you see on 7 and 8. And take a look at them. They're very similar.
7 product rule.
7 is a product rule.
8
is a composite function, so a chain rule.
All
right. Do y'all see the difference? Because here I am signing an x, and I am tangenting and 3x, and then I'm multiplying the two of them. Here I am signing a tangent of 3x, right? I can't split this up into a product because it's the sine of what? What is sine asking you to do? To find the
derivatives.
A regular sine is saying find the ratio of the opposite and the hypotenuse of whatever angle we're talking about. Well, there's no angle with the sine if you break it up like that. So this is a big chain rule. This is like the sine is like the f function, and then the tangent is like the g function inside, and then the 3x is like the h function inside of that. Are y'all seeing this? All right, so that should be reflected in the work that you're doing. What about number 9? So huge chain rule, right? You got a power rule with the 3 blah 2. Then you got to take, it's not a product rule after that, right? That's the cosine of that. So you got to deal with that cosine function. And then you got to deal with that sine function. And then you got to deal with that 2x. Are y'all seeing with that? So a big multi-step. So right here, well, let's look at number 9 since I'm seeing faces that don't show confidence. So right here, so the derivative, I'm seeing that 3 is like a 3 on the entire problem. So I'm seeing 3 cosine squared of the blah. Because when I see that three there is as if it was on the very outside like this in the red. I can't write it like that, but that's how I see it with my brain. So I go 3 blah 2, but I don't put the 2 on the outside. The 2 goes right in there. And what does that take care of for me? Just the 3. I haven't even gotten to the cosine yet. So then times. Now, what's the derivative of the cosine part? So I don't write negative sign. I write parentheses negative sign for the cosine part of the blah, which is the sine of 2x. That takes care of the cosine part. And then I go what? The derivative of the sine of blah, which is cosine of 2x. That takes care of the sine part. And then finally, the derivative of 2x is 2. Are y'all seeing that?
Is there like any real world application for this?
For derivatives?
Yeah.
Yes,
Oh.
tons. Yeah, rates of change.
Actuary,
What would
finance.
that mean?
A rate of change is a derivative. So you talk about growth rates in a hedge fund that you have. You talk about rates of change of velocity or acceleration, rates of change of productivity in a company. All these are, if you can come up with a function that represents the operations, the amount that's going on, anything, you can find where that is maximized. Oh, I want to know when would I maximize profit in my function here that represents my company. Oh, well, I can take a derivative, find where the slope is 0, and the slopes are 0 are usually at the high spots or the low spots, and I could minimize cost or maximize profit. Dealing with physics, there's tons of operations because physics involves velocity, acceleration, and position movement. When will I minimize my my velocity or maximize my velocity as a particle is dropping from space or whatever? I mean, there's all kinds of different applications that you can see. And I'm just talking off the top of my head. I mean, there's many more advanced applications of calculus, which is what we're doing. This is like, we call it pre-cal, but it's really calculus. You will start next year learning limits and derivatives at the very beginning. I think if you take AB, we spend maybe a week going over pre-cal topics that are really necessary for you to do well. I don't know that Helmers does that a bit. I just looked like when I taught it, looked through the curriculum and like, okay, of all the log stuff, what do you need to know? Put that in there. Okay, of all the conic section stuff, what do you need to know? Not much, but what do you need to know? Put it in. So it's just a big packet. I usually send home a summer packet. Helmers used to and then kind of quit. Whatever. He just expects more of you, I suppose. But I do make a packet for my AB students and say, here's what you need to know. But then I go over it for a week and then extra stuff too. But anyway, are y'all seeing this? Yes, no? What about something like number 11? What do you see here? So what is the very outermost function?
12.
That 12. So I got to deal with that 12 blah 11 first. That takes care of the 12. Then what do you see? A derivative of that thing all together because there's a big plus. So I would look at this and say, all right, to take the derivative of y, which just to shake things up, I'm going to ddx my y, which gives me dy dx. And then to take the derivative of the right side, I'm going to start with 12 blah to the 11th, and that will take care of the 12, right? Then you move to the inside, bless you. So I'm going to go times, and then I'm going to have the derivative of the inside part. Well, the derivative of the 1 is 0, so I really don't even have to consider, I don't have to write anything for that. And I move on to this part. What is the derivative of that?
3 sine.
So I start with the 3 and go 3 sine squared of x to the 5th. But all I did in doing that was deal with the 3. So then I move to the sine part. The derivative of the sine part is cosine of x to the 5th. And that takes care of that. And then finally, the derivative of x to the 5th is 5x to the 4th. And then I end that big parentheses. Now, I will say, and I hope she's not here for this, but there probably will be no problem that you ever do which will have an ugly derivative like this. I just overkill it in pre-cal. And believe me, I have pulled back. Before I taught calculus, I just had this sadistic way of like, okay, let's just see what they can handle. And I would give derivatives that would take like 3 lines to write out. And when I started teaching calculus, I'm like, why am I doing this? It's so stupid. But I always took pride that my pre-cals could do derivatives better than anyone. It was dumb. So you still will be able to do derivatives better than anyone, although you're kind of the only ones learning that at this point. But anyway, but you won't see stuff this nasty. You won't. Anyway. What else? Oh, number 14. What do you see? This is a big, giant chain rule. This right here is the same thing as me going like, okay, you've got y equals f of g of h of j of k of, and I don't know why I changed to parentheses, of L of pi x. And I'm taking a big chain rule derivative.
Sorry, do you not know the alphabet?
A, B, C, H, I, J, K, L, M,
No, I don't
X.
like putting eyes in there.
You can just have a.
It look like
all the
ones.
letters,
Whatever.
like a remembrance day.
Anyway, so here we go. What's the derivative of sine of blah? So check it out. So I have the cosine of cosine, tan, cotangent, secant, cosecant, pi x. Times, and that takes care of the sine. Now, what's the derivative of cosine?
Negative.
So negative sine of tan, cotangent, secant, cosecant, pi x. Times, and that takes care of the cosine. What's the derivative of tangent? Secant. So excited. Secant squared of what? Secant squared of cotangent of secant of cosecant of pi x times, and that takes care of the tangent. So I'm going to bring down here times what? The derivative of cotangent, which is negative cosecant squared of secant cosecant pi x. And that takes care of the cotangent times.
Secant tangent.
Now the derivative of secant is secant blah tangent blah. So the derivative of secant of that is secant of that tangent of that. So I need to copy the cosecant pi x in there. Cosecant pi x in there. And that takes care of the secant.
Cosecant, cotangent.
And then the derivative of cosecant blah is negative cosecant blah cotangent blah. So I need to copy the pi x in there. And that takes care of the cosecant. And then finally,
Times pi.
times pi.
Easy.
Now, the short answer to the question you're thinking is no, I'm not going to put something like that on your test, but it is a good lesson in can you think through the chain rule? And that's technically what the chain rule will be saying. Right? Okay. What about number 16?
Pi.
Now, let me ask you a question. You can go 5 blah 4. Is this 5 on the outside the same as something?
4.
Well, it's not the same as the 4, but it's in the same location as where the 4 would be. Does that make sense? So I don't really know why the 5's out there, except that I put it out there. And the key very well may say 5 blah 4. But that 5 because it's on the outside of the whole thing, could be put there with that 4, and you could change that to a 20, and you would have a much more simplified answer. If you don't do that, your answer that you get will just be less simplified, and maybe your answer on an AP test would have to be cleaned up a little bit. Not that you're going to see that on an AP test. Are y'all seeing that?
Wait, why does that work?
Because remember, when I write something like sine squared of x, what I'm really saying is sine of that x quantity squared. So anytime I have a quantity with that trig function, that too could have been written right there. And it would be written like that. So it's not going to be written like this. You're not going to, but if it was, that doesn't mean you can't do this problem. Doesn't mean that you can't say the derivative is 5 blah 4 to deal with that. You can, but when you're all said and done, you're going to look at this and go, wait, I could have combined those secants together. Right. Anyway, just a thought on that. What do you see on number 19?
Quotient, and then
A big quotient rule involving the whole thing, right? But as you're going low D high, what's the D high? A big ugly chain rule, isn't it? Starting with that 3, then the sine curve, then the 4, then the parentheses. And then you're going to go minus high D low. When you get to the D low, another big chain rule, right? And then over the low squared. And by the way, when you write the low squared here, remember, like if this is y prime and you put it all out there, should you write the low squared? Is this correct? The low squared. No, that's not right because you're not squaring the 3. Is this correct? Kind of, but bad form, and I probably would allow it. But what would be better was what? Secant to the 8, because squaring the whole thing, that's the whole thing right there. So changing that to an 8 would be a better way to write it. Now, again, I might not have done that because I forget from year to year how much I want to kind of raise the bar. But it would be better to change that low squared that way. Y'all with me? But I don't think I would count off if you put the whole thing in there and square it. You just won't ever see it like that on a multiple choice test. All right. I'm pretty sure I did not want to do implicit today. So what I want you to do is finish up that more trig derivatives, which has got a lot of problems on it, but you might be able to get it done. And then there's a review number 1. Okay, I have 2 reviews for this test, but this is review number 1. So if you can knock out one of these in class, you can do the review for the homework. And if you can get that done, you're probably putting yourself in a really good spot to do well. You with me? All right. Good times. Feel free to collaborate. Ask questions of your peers.
Stuff for like another class.
Rather you not. I'd rather you not, so that when Maddie runs into trouble, she can seek out your help and you'll be on the same page. You know? Literally causing trouble again? Yes. All right. So guys, don't do that. For the record, don't do that. Is this what this is called? Yeah. Don't do that implicit. You don't know how to do implicit. I've kind of briefly mentioned it, but you don't want to mess with implicit. There's a thing titled implicit differentiation, one of the worksheets. Don't do the one that's titled implicit differentiation. If you get stuck, let me know.
In your key, you didn't change rule of this. Don't you have to?
What?
Oh wait, should just be X.
Well, no. Like, remember, I'm doing a chain rule of this, not of my answer.
This is part of the chain rule.
Okay, so I'm going 4 blah 3. That takes care of the 4. And then I'm doing secant blah tangent place blah. That takes care of the secant. Then I'm going 3 blah 2. That takes care of the 3. Then I'm taking the derivative of that. That takes care of that. What's left? Don't look at your answer and go, I'm taking the derivative of my answer. If you do that, you're going to end up with times 0 every time.
Okay.
I think what you're doing is don't have to take the derivative of this. You're looking at your answer. I'm looking up here.
Yeah, so you're
I'm
done.
doing one thing and I'm done. That
And then
part was the
cross
result
off
of
this.
cross that off.
Wait, but it's-
Other than that, it was folded wrong.
Sure.
The ability to.
Distracted with the peers. All right, fun boy. Come on, guys. Let's focus. Sure. So number 10, I'm going to give myself some space. I need it. Just say this took me a little space. So I'm going to go y prime. Come on. Y prime. So low times the derivative of the high. So the derivative of the high would be 0 plus the derivative of that. Well, the derivative of a cosecant of blah is a negative cosecant of the blah, cotangent of the blah. You can copy that blah down. And that would take care of the cosecant part and then times the 2x. All right, and that takes care of that part. So this is my low D high, and then I'm going to go minus high. I'm going to run out of room here, so I'm going to start writing really small. There's the high part. And then the D low, again, is going to be 0 minus, and the derivative of cotangent is negative cosecant squared. So negative, and you can put 2 negatives or just change that to a positive. Cosecant squared of that, x of that blah, times the 2x. So that's high D low. And then I'm going to put all of that over the low squared. And I'm not putting that 2 with the cotangent there because it's joined by addition. And I can't just square each term. That's not how math works on an A plus B. On an A times B, you could do that, but it's an A plus or minus B. You'd have to FOIL it.
Is that dot a negative?
Well, it was 2 negatives that turned into a plus, but I don't need to have a plus.
Could you, so that's not the definition of the.
So it's, I'm sorry? Say it again?
Isn't it like one of the definitions of the?
Like one of my trig identities? Is that what you're
No,
saying?
it's like the limit of x that approaches a is x and something.
It's a definition of verb.
I don't see that there, but I don't even have a limit. So if I don't have a limit, that's not a definition of a derivative. It's just some random function.
It just looks like.
Yeah, but I don't see an x plus h in there. I don't see an a in there.
Okay.
So I don't see anything. Anyway. By the way, y'all need to start warming up, getting your stuff down because we have the trig derivatives game this year. It's on the schedule.
Oh,
Big fun.
so you better be ready.
So true.
Look at how all the dude was doing.
Where did it go? Oh, yours.
He went to Nashville.
Best in Nashville.
Sales best friend.
Okay.
Oh.
You got Hill. I don't know if you remember that. Hill just wouldn't stop. I mean, Abdul wouldn't stop talking for freshman year. So the guy threw out during the state tournament test, threw out both of their tests, and Hill was like, he did a major turnaround last year. For those who were not in his class, most don't believe that. Hill's like, I don't even believe it.
Mr. You should have met Gilder.
Gilda?
I don't think he was fun. Yeah. Mr. Harry would have retired a year earlier. Yeah.
He was in Homer's class?
No.
He was in middle school.
Oh, in middle school, so he never made it to the high school.
And like this coolest festivals, everyone like made him read when we did. Everyone always just chose him.
He like.
He made a read in that class.
No, I don't think you would handle him.
Everybody,
Bounce
you know, I hear that about everybody, every class, I always hear, oh my gosh, it's the worst class ever from the middle school. And I'm like, they're pretty great for me. Like I always hear that. And then they show up in my class and the worst case scenario is I have to kind of give them the cold shoulder a little bit and kind of maybe have a conversation. But usually they figure life out really quickly. And it's the freshman year that they're kind of boneheads, and of course, middle school everybody's boneheads.
It's also like,
But-
if you don't like your teacher, you're probably not gonna respect.
Yeah,
There's
maybe a little
some
bit too.
teachers that a lot of people really like.
Well, and like even I remember Kaylin saying that like she drove her teachers crazy, or you maybe said that like because your personality was kind of bubbly and fun,
Yeah.
it would just drive them nuts. But like to me, that's fun. It adds to the class. And I did. Like I was always out in the hall for talking too much or getting D's in conduct. Like I only made the honor roll in middle school twice because if you had a C or worse in conduct, you couldn't make the honor roll. So I have straight A's but like D's in conduct. So annoying. Yeah. I know. No, we had a superintendent here in the 90s who got up there a couple years before he retired. And he was like, and he was just talking to the faculty. He goes, and here's another thing. There is no, he said this, and we were like, please retire. And I liked it. He'd give me free Auburn tickets. But he would go, there is no place. And I was ready for something serious. He goes, there is absolutely no place for gum in the classroom. And I went, did you just like, really? That's where you're going to take your stand on gum? But yeah, all my teachers were, you look like a cow chewing on their cud. I mean, I heard that 100 times. I'm like, I don't even like, I have no idea. Like, is there anybody who chews gum like every day?
Yes.
Like I've never noticed. Like I can't even fathom noticing that. It's so funny to me. Does that answer your question? Or what were you?
I like, I know the guy. Way that you wanted us to go.
Now I will say, like, what if I gave you this question? What if I gave you something like, and I could do this. All right, guys, so what would you do on this one? This is 12B.
Is it 1 minus?
Okay, so like technically to take the derivative of this, you'd have to go first d second plus second d first. And when you got to the d first, you'd have to go low d minus high over low squared. But if you look at this and go, wait a minute, that is sine squared. I'm not taking a derivative, I'm just simplifying. That's a cosine squared. that over that's a tangent squared, and a tangent squared times a cotangent squared is a 1. So the derivative of the 1 is 0. And you can make it a lot easier on yourself.
Shut up, Luke.
Now that, guys,
First identity we ever learned.
yeah, pretty much.
That is a trig identity, but I couldn't want it in.
True that.
Well, sorry.
Thank you for praising me.
I will say that those are the ones you need to know for calculus. The Pythagorean identity, sine squared plus cosine squared is 1. Oh, not a math class, but any other class? I think I would love like an English literature, even though I stink at reading for comprehension and foreshadowing and all that crud. But the idea of being able to like just have a conversation,
There's a
like say, hey, what do you think? And talk to me about this, or what do you think this implies? Really engage conversation. That would be really cool to get somebody to think.
Try and start a class like that. Engaging. Yeah, engaging words. You just like read books and stuff.
Yeah. What they should have is mandatory for every kid a finance class.
Yeah.
They should have that over a semester. You could teach a lot about the kid that could really use.
Trash in the school. That is, I will stand by that
State
the rest of my life.
But if you did something like how to start a small business,
It is an excuse
how to apply for a license to do home repair or whatever. I mean, like little things, how little things like that. So a kid, when he doesn't go to college, can go,
How to do your
hey,
own
I can go
W-2?
buy some land equipment and or some yard cutting equipment, start a little yard business. I mean, you make a fortune cutting grass.
My most
You
useful
know?
class was a backup that I took first semester, and it was public speaking, and no one had ever like talked.
Oh, I
about
didn't take a
this.
public speaking class in college. It was great.
And I could do my homework most days, but like when we were like doing stuff, it was so helpful.
Yeah. Helps you just get past your fears of being up in front of people and
Yeah, it was like, I don't know, people have little like nervous things they'll do, or like they'll move around, or it's just how to like think on your feet and phrase things, and also how to like give a speech. And it talks about, when you talk about the kind of how you want to present your words in different situations. And then we talk about interviews. And so there's like a portion where you interview other people and they interview you. They're just,
I like that.
it helps. Like,
yeah, no question. Yeah, it seems like you had to take that in business at Auburn when I was there, because I remember taking it.
It was so stupid, like, we had to take like tests, Word documents and PowerPoint. You're like, Jesus.
Yeah.
that's all. Procrastinated on most of every class I've ever taken, and we went virtual. And then I did 0 period. We went virtual, and I had done like maybe a 10th of the work, and I had like an F in the class on the last day. And then Coach Bagley called my mom, and she made me do all the work, and then I finished with an A. And I did it all in one day.
Whoa,
But I
you
never
did the
took it.
work and finished with a good grade?
What a correlation.
Oh, there's no way this is
It's
crazy.
never happened before.
That's not how that works.
It's not that, like, health, I don't remember anything from that. Like,
Yeah.
I just Googled all the answers.
I remember a health
No,
teacher had
you
to
did it
use my
all the way
room one
through.
year during my off period, which stunk. But I would just, he goes, you can stay in here and do your work, fine. So I would sit in here, and I remember every day, this is when I realized, gosh, I'm teaching the wrong subject. But he would come in every day, this health teacher, who's long since retired now, but he would walk in with his book, and he would just open his book up, and then he would just read through there and define the definitions that were already defined in the book. And then he would which would take maybe 15 minutes of whatever part he was covering. And then he would ask a question and maybe get into a random topic conversation for another 10, and then they would do nothing for the last 15 to 25 minutes. And I was like, he's getting paid what I'm getting paid. Actually, he was getting paid more because he was also a coach. So he would go and cut. He didn't have to do any prep, right? And he was given Scantron tests, so it didn't take him any time to grade. So he would go coach different sports after school to make an extra 15 grand a year. I was like, what? Thing's broken here.
I feel like you'd have so much fun, like picking a book out for the class and like, you have Socratic seminar every day, like I feel.
Yes, you really can.
For doing like math.
I do actually. And I would say, as far as math team teachers get paid, I probably get paid more than anybody in the state by a long, big margin. Like they give money for me to do each class and to coordinate the math team. So it's actually a pretty good stipend. They have been very kind in that regard. Like they didn't have to be.
Well, you do.
Like the guy at Mountain Brook, when he was at Hoover, and he was really good. Like that guy was a genius, and he ran a tournament and did all this kind of stuff. But they paid him $2,000 a year. I'm like $2,000 a year? I said, how many hours you put into your tournament? He goes, probably 200. I was like, so that's $10 an hour just for the tournament. He goes, I know, it's stupid. It's not anything, but something. I'm like, no, it's not anything. You could make more than that working at Taco Bell.
Russell and both make more than that.
Yeah. So I'm saying like it was a joke. And that was just the tournament, not counting all the things he did after school for morning sessions, after school sessions with his math teams and stuff. It can make a lot of money. Yeah. You don't make it off the high school level. You make it off those 6th and 7th grade. You know, so the ones you don't really want in your building because they're just little snot-nosed kids running around, and you know what it's like, and you're like, I feel like I'm among the great unwashed, just parting the sea of filthy 6th grade humanity. They all just gross me out, especially the nerdy ones, that come to the math tournament. It's like they've got crumbs on their chin from their donut and the boogers, and it's just, you know what I'm talking about? I mean, look closely. It's like,
You don't need to look closely.
your parents don't take care of you. I don't know. But that's where you make your money. You bring those in by the busload,
You sound like you're cattle.
They are. Because I remember saying, well, if I did a tournament, I would only do one for the high school level, kind of like Briarwood does. They only do it for 9th and 10th grade, but there's no money there. You just don't make a lot. Oh, maybe they do one for 8th grade too. Maybe for Algebra 1 also.
Last time we went to Briarwood, it might have been like 9th or 8th grade. They did like math stand-up comedy in the theater.
Oh my God.
I don't remember that. It's pretty funny. Just random people got to come up to the mic.
Briarwood students, like the.
Oh, the Briarwood website, because it's kind of risky. Just letting anybody grab a mic.
Mr. Ray, can we please host one here and like maybe the people like, okay, you're gonna.
You'll have to talk to your new math two sponsor. That's so true.
That's so fun.
Most of the students you see at tournaments, they either make it a requirement or they bribe them with points or do something. Or you off the pay, they get some extra, like you gotta get so many hours or like honor society, so they'll bring them up. They find everybody. Oh, Grissom?
No.
No, that was Muscle. Oh, Muscle Shoals is one?
Gilder was trying to. Here's a good Gilder story for you, Mr. Hurry. He was trying to eat. For some reason we had like breadsticks. It was that from?
What's it new?
Yeah, just the news. He had a bunch of breadsticks. He was trying to eat them all at once from the bus, and he choked. And no one helped him. They just laughed at him. He tried to go help him.
He was choking like coffee choking or
On
honey zoom choking.
a breadstick, and no one helped him. He tried to go help him. It was so sad. And then he was under the bus seats for some reason. I don't remember why. Like under a bus. Oh, was it the chips?
This voice knows this.